Alright guys, welcome back. I hope you guys had a great break. What we're going to do to start off the semester is one of the most important things that you did in Algebra 2, and that is factoring. So the first thing we're going to do is we're just going to look at a couple of the different ways that you can factor that you've already learned. Now, no matter how you factor, the first thing that you always do, your first step is always to take out the greatest common factor. You always take the greatest common factor out first, no matter what kind of factoring you're doing. Then, after you've done that, you look and see how many terms that polynomial has. So if there were 3 terms, then that is just normal factoring, whatever method you learned in Algebra 2. With a lot of you guys, that was your AC method, where you split the middle. Some of you learned how to factor with the box. Some of you just guess and check. But however you factor with 3 terms, however you learned that in Algebra 2, that's what, or actually in Algebra 1, however you learn to do it, that's what you do with 3 terms. Okay, if there are 4 terms, that's a little bit tougher. You looked at those in Algebra 2, that's when you need to use grouping. And then sometimes you have just 2 terms. So then if there's 2 terms, there's a couple different options you have here. If those 2 terms are perfect squares, that means you know the square root of the first term and you know the square root of the second term. Okay, so that means if you have something in the form of a squared minus, b squared, that is a difference of squares. And you guys are used to seeing those from Algebra 2. A squared minus b squared factors into a plus b and a minus b, where a is the square root of the first term and b is the square root of the second term. Okay, then you also could have had perfect cubes, so something that you know the cube root of. So numbers that you know the cube root, those are numbers like 1 or 8 or 27 or 64. So numbers that you know exactly what the cube root is. And with cubes, you can do the sum or difference. So if I have a difference of cubes, so I know the cube root of a and I know the cube root of b, and that can factor into a minus b, where a is the cube root of the first term and b is the cube root of the second term. And then the rest of that is whatever a is squared plus a times b plus b squared. Then the other option, very, very similar, but you could also have a sum of cubes. That actually does work out. So if you have a cubed plus b cubed, that can factor. If it's squared and it's plus, it cannot factor. But if it's cubed, that's okay. So that's going to factor into a plus b, a squared minus ab plus b squared. So those 2 formulas are very, very, very similar. The only thing that changes is the plus or minus sign. So if you look, that's the only thing that changes. And a lot of you guys learned the way to remember those signs. A lot of you learned it with SOAP, which stands for the same sign, then the opposite sign, and then always positive at the end. Okay, so what we're going to do is we're just going to go through a couple different examples of all the different kinds of factoring that we're going to have. So we're going to start with this one over here on the left, 49 minus 64x squared. So remember, our first step is always to take out our greatest common factor. So is there a factor common between 49 and 64? And there's not. So if you look, this is 2 terms, and it's a subtraction sign, and I know the square root of the first term, and I know the square root of the second term. So this function is in the form a squared minus b squared. It's a difference of squares. So I know the square root of the first term. The square root of the first term, a, is 7. b is going to be the square root of the second term. My b term is the square root of 64 is 8, and the square root of x squared is x. So this is really simple. It's just going to factor into 7 minus 8x and 7 plus 8x. So the sum and difference of squares can be really, really simple if we just look at those. All right, now my next one over here on the right, I've got 8x cubed plus 125. So if you look at this one again, it's two terms, and this time with the two terms, this is a sum of cubes. So I know the cube root of the first term, and I know the cube root of the second term. So just so we remember, a few numbers you guys are going to want to get used to seeing. 1 cubed, you guys know is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Those are the ones you're going to see most often when you're factoring. So this one over here, this is a cubed plus b cubed, so we know how that's going to factor based on that formula that we had on that flow chart. So we just need to figure out what a is. So the cube root of the first term, my a, is going to be 2x. My b is going to be the cube root of the second term. And the cube root of 125 is 5. So I just plug in that a and that b into that formula that I had from the start. So that formula for the sum of cubes is the a term plus the b term times the whole a term squared. So it's 2x, the entire thing is squared, including the first number, so it's 4x squared. Then it's minus a times b, which is 10x, plus, because the last one's always positive, the b term squared. And that's as far as that one can factor. Alright, so my next one that I have here, remember what we said our first step always is. And we said that first step is always to take out the greatest common factor. If there's a common factor, you always take that out first. And if you look at these two terms, both terms are divisible by 2. So the first thing I'm going to do is I'm going to factor out that 2. So if I factor out 2 from 54, I'm going to be left with 27. If I factor out 2 from 2x squared, or 2x cubed, I'm left with x cubed. Now the inside, I'm left with a difference of cubes. So I have a difference of cubes where a is 3 and my b is x. So now I can just factor the bottom using that difference of cubes formula. So it's a minus b times a squared plus a times b plus b squared. And that's as far as that one can factor. Okay, so the big thing on that one is to remember you always, always, always take the greatest common factor out first. When you first look at that, you can't tell that it's a difference of cubes until you take out that greatest common factor. Alright, so we got two more that we're going to look at. Now this is when a lot of people start to have trouble with factoring, is when that first term is a number greater than 1. So a lot of you guys are really good at that, finding out what the two numbers you need to multiply by are, but when this first number here is not 1, there's a little bit more work required. So we're going to start this off the same way we normally start off. I need to multiply 6 times 15, so 6 times negative 15 is a negative 90. I need two numbers that multiply to negative 90 but add up to a positive 1, and that's because my middle term is 1. So two numbers that multiply to negative 90 and add up to 1, those two numbers are going to be a positive 10 and a negative 9. So what I'm going to do with those two numbers is I'm going to rewrite this equation, except instead of my middle term being just x, I'm going to rewrite that middle term using the two numbers I just found. So that's going to be 10x minus 9x minus 15. And if you look, nothing in this equation has really changed. I just rewrote it by splitting up that middle into the two numbers I just found, because 10x minus 9x is still that positive 1. So it hasn't changed the equation in any way. So now what we're going to do is we're going to group this, and we're just going to look at the first two terms. Now in those first two terms, we're going to take out our greatest common factor. So the greatest common factor out of those first two terms is a 2x. If I factor out that 2x, the first term is going to be left with 3x. And then the second term, if I divide out 2x, all I'm going to be left with is 5. So after I have that done, I'm going to go to my second half. And I'm going to group the second half. I'm going to keep that same sign that I have, so I'm just going to keep that negative. And then I'm going to take out the greatest common factor of that 9x and 15, and that greatest common factor is 3. when I divide out 3 from 9x, I'm left with 3x. And if you remember, I took out a negative 3 here on the outside. So when I take out that negative 3, I'm left on the inside with plus 5. Now you'll know you did this right if when you look at your final answer, what's left in parentheses is the same. If those two things match, you know you did it right. So your final answer is going to be the part that matches, and then everything else that's not in the parentheses is your other factor. So what's not in the parentheses here is the 2x minus 3. So that's my second factor. So that is my final factored form. So if you look, we couldn't just take that 10 to the 9 that we originally found. We had to do a little bit more work. All right, now the last example we have is an example of grouping. Now this is a 4-term factoring. Okay, so if you look back in that flow chart, we said when we have 4 terms, we have to use grouping. Now what's really nice about this is really that's what we just did at this step. We're really just doing the exact same thing, where we're just going to look at 2 terms at a time. So we're going to start just by looking at these first 2 terms. So x to the 5th minus 4x cubed. We're going to find our common factor. And the common factor I have there is x cubed. If I divide out that x cubed from those first 2 terms, I'm going to be left with x squared minus 4. Then I'm going to look at my next 2 terms. So if I look at my next 2 terms, I'm going to keep the same sign, so I'm going to keep that minus, and I'm going to take out my common factor. But if you guys look, there are no common factors. There's no factor common between x squared and 4. So all I'm going to have is a 1. And then in my parentheses, I'm going to be left with x squared. Remember, there's a negative in front, though, which means if I divide that negative 1, I'm left with minus 4. So what I need to happen is if I go back and multiply that back out, I need to get the answer I have at the top. And that has to be a minus in order for that to happen. So now, again, we're going to look at our next step. In order for this to work out, I need the parentheses to be the same. And the parentheses are the same. So x squared minus 4 is my first set of parentheses. Then I look at everything else that's left over. That's x cubed minus 1. And that's my second set of parentheses. And I would be done here, except this one is actually a little bit trickier. So if you guys look, you actually can simplify this even farther. If you get to this step, that's good. That means you know how to group. However, this can simplify farther using our rules that we learned earlier. This first set here, x squared minus 4, that's a difference of squares. I know the square root of the first term and the square root of the second term, which means the first factor is actually going to factor farther into x plus 2, x minus 2. And then the second one, that's a difference of cubes. So I know the cube root of the first term is x, the cube root of the second term is 1. So this is going to factor using my difference of cubes formula that, again, I've already done. That's going to factor into x minus 1 and x squared plus x plus 1. And now that equation is fully factored. And that's it for factoring.